introduction to process engineering design, interaction with other engineering disciplines, process design basis, process design philosophies, and various diagrams, process engineering diagrams, starting from block flow diagram, process flow diagram, process safety flow diagram, P&IDs, etc. Then from drawings, we further went into the hydraulics, line sizing. What is by line sizing? Pump hydraulics. Then we did sessions on equipment design, process equipment design, starting with vessels and separators. Then most importantly, one heat transfer equipment, that is heat exchangers. Then the important mass transfer equipment, columns. So after that, we had another important topic on process control system and safety systems. Now to conclude the session topic 14 is on piping valves and control valves. So this is another important component in the process system. Valves regulate, allow the flow to happen. Also they regulate, they close, take a shutdown, etc. So it takes, they are really operating the plant. If you want to operate the plant in a very effective manner, so you need these devices. So let us go into the session. So this being the last session, I would like all participants, hope they all have taken enough notes, and I'm sure all the presentations have been shared by iFluids. And I take this opportunity to thank iFluids Engineering for providing this platform and an opportunity for me to give you training on the important process design topics. And also the coordinators, mainly John Kingsley and Premnath, who have been the main persons arranging all these presentations. And also be in touch with all of you, all the participants, and distributing the technical material, question and answers, etc. So last 3 sessions, the question and answer preparation is going on. That I will share in the due course. Prem, after this session also, you will be in touch with them, correct?
Sure, sir.
So whenever I send the question papers for the balance, I think 12 honors it is pending, 12,
Yes.
13 and 14. So I will prepare them maybe in another 2-3 days, and I will share it with you.
Okay, sir.
So then it's my pleasure to present to you my process engineering design topics, and also it's an opportunity to share my experience with all of you. So let us get into the today's presentation, piping valves and control valves. So the table of contents, today's topic will be introduction, types of valves, control valves, and control valve flow coefficient, control valve flow characteristics, control valve specifications, types of control, and control valve sizing calculations. So what do you mean by valves? Valves are the manual or automatic fluid controlling elements in a piping system. Okay. Valves are very important. As you all are aware, even in our body, we have valves spread all over the body in the blood vessels. Okay. They allow flow in a particular direction. And also in the heart, which is pumping the blood throughout the body and get the impure blood back, and then send it through lungs, get it purified and bring fresh oxygen to the bloodstream, then again distribute it all over the body along with the food nutrients, correct? So in the heart also, you know, there are some complex valve arrangements are there, triple fold valves, double fold valves, etc. So valve in nature, our body itself have a lot of valves doing important functions. The industry, the valves allow the flow of fluid through piping system, allowing the flow, and you also can regulate the flow with the control valves, and you can close down and stop. Shutdown valves do the job of closing or opening, allowing the flow or stopping the flow. So this is the main function of the valves. Without valves, you cannot imagine the operation of the plant. So the walls also are constructed to withstand the temperatures, pressures, corrosion, mechanical stress, because it is part and parcel of the process system facing the process fluids. So the operating pressure, temperature, the corrosive nature of the fluid, etc., and also the stresses induced due to temperature and pressure. So the walls also have to be designed to withstand these service conditions. So that just now I explained the function of the valves is starting, stopping, and directing the flow, regulating, controlling, and throttling the flow, preventing backflow, relieving the pressure, excess pressure. So an interesting factor is the valves may cost up to 20 to 30% of the piping cost. Okay, it's a significant cost component in the piping system. The cost of a given type can vary depending upon the type, size, and material of construction. So the wall cost is basically based on type of wall, size of the wall, and material of construction. You all know some simple walls like gate wall may be cheaper compared to globe wall for the same size. The same type of wall, 2-inch wall may be cheaper, 4-inch wall will definitely be costlier. Material, if it is carbon steel, definitely it will be cheaper. If it is made of carbon steel or some exotic material, the cost will be high. So what are the main components of the wall? The picture shows you the wall components. Okay, they are listed here. Body, this is the body. Number one is the body. This is called the wall body, and this is the pipe connected to the wall, and this is the flow direction. Somebody is not muting the microphone, so let us all mute the phones. You can keep your questions towards the end. Okay. So the port is called this one. Okay, these are called the ports. Seat is the place where the valve trim goes and sits there. This is the valve seat. Stem is the rod which is allowing the movement of the valve through the valve body. Disc or the valve trim which is doing the action of opening and closing. This is called the valve disc. Hand wheel is the one which is used to rotate in the clockwise or anti-clockwise direction. If you do it in the clockwise, it will close. If you do it in the anti-clockwise, it will open. And bonnet is the portion which is holding together, okay, which is holding together the valve along with the packing material. We all know there is a minor clearances between the mechanical components, so there may be leakage. To avoid leakage, we put some packing material. 8 is the packing material. This yellow color is the packing material which prevents the leakage of process fluid through the then there is a gland nut tight, allowing the leak tight connection. Fluid flow happens. It is the direction of the fluid flow. A disc we have already seen. Disc will go down when it is closed. The disc will sit here, and hand wheel we have seen. Okay. So all the components I have already explained, which is again given here. The wall body is the outer casing of the wall that contains all the internal parts. What you will see outside. Okay, body is the one you see outside. From the shape of the body, you can determine the type of wall. So that we will come to know on the subsequent slides. Bonnet is the cover for the wall body, and also it accommodates the stem packing, etc. During the manufacture of the valve, the internal parts are put into the body, and then the bonnet is attached to hold everything together inside. So disk is the real member which is moving up and down and provides the required opening or closing or opening of the disk.
Hello, sir.
जो 10th में सोचेगा मुझे शादी करनी वही मेहनत करेगा.
I'll speak with the trainer. Just mark your attendance and wait.
जैसा माहौल बना दिए देगी जैसा उस पे नहीं करना है.
He will be connecting. There is some internet issue, so please stay tuned.
Host disabled means you have to allow, I think. You have to allow. Okay. Now I think it is working, Prem. People are still joining anyway. So, friends, sorry about the interruption. There was some internet problem at my home.
PPT is not visible, sir.
We can start.
PPT is not visible, sir.
PPT is not visible.
Only
Right?
your Explorer, Windows Explorer is visible.
Share, I put share only. It's not coming.
Share screen. Now it is showing your mouse piping and module 14 it is showing.
Now I am opening the PowerPoint.
But it is not coming up, sir. Like
Wait.
you have to share the whole screen. You have to share the whole.
I have to come through again.
Okay, sir. You close and you can come through.
Now the screen share is there. No.
No, sir. Share now. Sir.
That is not coming. Wait. I will come back. So, Prem, am I audible? Prem?
Yes, sir.
Okay, I will do the. You have to allow me to share the screen.
Yes, sir. Allowed, sir. You can press Alt S.
So, still people are coming. Okay. Now the screen is appearing.
Yes, sir.
Now it is okay.
Yes, sir. PPT is.
Maybe it is. Okay, now we can see, correct?
Yes, sir.
Okay. So, to all the participants, sorry for the interruption in between due to internet connectivity. So, we have seen the contents and walls function, wall construction, and the seat is the place where the wall disc goes and rests there. The interior surface of the body which contacts the disc to form a leak tight seal. Okay. And in the seat, there are two types again, hard seats and soft seats. Hard seats are integral to the wall body. It is made within the body itself. So nearly all hard seated metal walls have a small amount of leakage because it is a metal to metal. The Seat is also made of all body material, and the disc also is metal. Even though you do fine finishing of the surfaces, a metal to metal joint, always there is a minute leak is possible. So the examples of hard seated valves are gate, globe, and check valves. You will see what are these. I will show the pictures, then you will easily understand the type of valves. Soft seats are fitted with valve body and made of soft materials, elastomers, such as PTFE is a plastic material. So example, butterfly, ball, plug, and diaphragm valves have soft seats. So trim is the internal elements of the valve which are collectively referred as a valve trim. And trim consists of stem, seating surface in the body, stem hole guide, and small internal parts that normally contact the service fluid. The trim is the portion which is actually in contact with the process fluid. So trim material is very important. So the valve selection, how do we select the valve? There are different functions of the valves. Based on the function, we select the particular type of valve. Operation wise, we have four categories. One is on-off valves. These are, the name itself implies it is an isolation valve. It has only two positions. Either it is fully open. On means fully open. Off means fully closed. So it has only two positions. There is nothing in between. So these are mainly used for shutdown valves, etc. When you want to isolate a system, we use the isolation valves, on-off valves on the upstream and downstream of the equipment. So the main example is the shutdown valve. Throttling valves are for controlling purposes. When you want to control the pressure inside a vessel or temperature of a hot medium or the level control valves, these are all throttling valves because they will move between open and closed position. According to the process requirements, they will have different percentages of opening. Okay, these are called throttling valves or even control valves. And another important category is non-return valves. In some cases, we want the liquid to flow in one direction only. There should not be any reversal. Main example is pump outlet. Pump discharge line, we always put a check valve because if there is a reversal of flow, the flow direction changes. It will, if it goes into the pump, it will damage the impeller of the pump. Okay, reverse rotation. To avoid that, we have to prevent the reverse flow. We use non-return valves. Multi-port valves, we can have one inlet and many outlets, or two inlets and going to two outlets. Correct. The multi-port valves are specifically used in operations like the air dryer. Let us say air dryer. We remove moisture from the compressed air, which is used for instrument air function. So there will be two vessels. One will be absorbing the moisture. Other vessel will be in the regeneration mode. So we switch the air stream between the two vessels. There we need the multi-port valves. And the type of fluid determines the metal of construction type of valve. Okay. If the fluid is clean liquid, there may not be a problem. If it is a slurry, has some solids, we have a certain type of valves for that. So the fluid determines the particular type of valve. And of course, pressure and temperature will determine the valve mechanical characteristics, mechanical requirements. Of course, cost is very important. For a given service, the valve should meet all the process conditions, and also we have to select that particular valve with which is a reasonable cost. Okay. Then availability is, valve is whether easily available in the market or we have to order and wait. In emergency situations, we will immediately require the valve, means you cannot wait for the valve to be fabricated and supplied. Okay. So on-off valves are for the isolation purposes, which we have seen, and they will either open, allow the flow fully, or close and block the flow. So these are all the valves which can be used as on-off valve: gate valve, ball valve, plug wall, butterfly wall, diaphragm wall, and pinch wall. I will show the pictures, then you will have a better understanding of the type of walls. So this is the gate wall. See, you can see this is a gate wall. This is called, this is like a gate. It's a disc, a circular disc which is going up and down. When you open, the disc goes up and allows the flow to go. When you close, the disc comes down and seats in the seat, wall seat, and then closes the passage and stops the flow. So this also can be used as on-off wall. All the components are shown: hand wheel, stem, gland packing, bonnet, then body of the wall, and then this is the seat. This is the seat, and this is the gate. This is called the gate, wedge-shaped gate. So the gate walls are designed to operate fully open or fully closed. Because they operate slowly, they prevent fluid hammer. Means it doesn't slow. Suppose you close the wall, all of a sudden what happens? It has a mechanical shock. If you suddenly close the wall, fluid keeps coming. There will be a mechanical hammer. It will be having a impact. So that is called hammer. So this wall is slowly closing, slowly opening. So there is no danger of the hammer, and this allows for full flow through the wall. So pressure drop is very little through this wall. And gate wall opening closing looks like this. Okay, so if you turn this way, this is the clockwise direction. Clockwise direction, it closes, and if you turn the other way, it opens the wall. Okay, this is the gate. The gate is down when you close, gate is up when you open. There are two distinct types here also. The stem rises, and when you open, the stem comes out. When you close, stem goes in. There are specific type of walls which is called a non-rising stem. Stem will not rise. It will be revolving within the body, and only we will not know whether the wall is open or closed. But in the rising stem wall, we will know if the stem is outside, the wall is open. If the stem is inside, wall is closed. Both types of walls are available. Ball wall, the name implies the wall body. Inside the operating uh, part of the wall is in the shape of a ball, and there is a opening. You can see the opening here. The opening, when you match the opening with the pipe ID, it allows the flow. And there is a lever on the top of it, and when you turn it, it closes. It is a quarter turn wall. It is called quarter turn. When you turn the handle on the wall by 90 degrees, see, this is the wall. Okay, you can see the handle here. So the ball, it explains the operation much better. The flow is like this. It is in the open condition. You can see the opening in the wall, and in the ball is matched, so the flow is happening. When you turn the lever to 90 degrees, the blank portion comes and occupies the wall body. It stops the flow. So valve is fully open, valve is half open, valve is fully closed. Just a quarter turn, 90 degrees turn of the handle. Plug wall is something similar to your ball wall. The shape of the trim is different. You can see the trim looks like this. Trim looks like, instead of a wall, it is in the form of a plug with the opening here. Again, matching the opening with the pipe ID, the flow is allowed. When you turn it 90 degrees, it will close the wall. Fully, these are also, you can make it fully open or fully closed. And plug walls are available in much larger size than ball walls. When you need the same function but in a bigger size, you need this kind of plug walls. The plug wall operation is explained here. Plug wall operation is explained here. So just like the shape of the plug is like this. If it is a spherical one, it is a ball wall, and this is a plug shape, and this is a plug and opening. This is called port. Okay, the handle is here. And again, you have the usual body parts of bonnet and packing and the wall handle, and this is the stem. Okay, The flow, it shows, the bottom one shows the flow is closed. When you bring it to this direction, some parts they say open close will be marked on the valve body itself. Okay. In some cases, when you put the lever along the piping direction, then it is open. If you turn it to 90 degrees, the valve is closed. Okay. Other one is butterfly valve. The name itself indicates that the valve, uh, the opening closing part is like a butterfly. See this one. Okay. So this shows how it operates. This, the hand wheel is put this way with a gear arrangement. So it revolves within the valve body. So if it is in this direction, it allows flow freely through the valve. If you turn it this way, it closes the valve. Okay, so this is how it looks like. And these are also quarter turn valves, 90 degrees. They are generally used for handling large flows of gases and liquids, including slurries. The advantage is they can handle slurries also uh, with solids. The seat will not be damaged. And more popular in industry because of their compact design. It doesn't occupy any space. If you see the other types of valves, the valve body occupies certain space, but it is only a flat piece of element inside the valve, so it is very compact in size. It is usually used for sizes 3 inch and above, because smaller ports pressure drop is more. And then diaphragm valve, here you see this is the diaphragm. The diaphragm is pressed by the valve stem and a compression part here. The valve position indicator, it shows the position. This is the bonnet and this is the hand wheel. Okay, and this is the pipe connection. And on the seat, the diaphragm is pressed against the seat, it closes. When you open the valve, the diaphragm is lifted and it allows the flow. It's consisting of a saddle or seat upon which the diaphragm closes the valve. Diaphragm valves are used whenever the fluid is highly corrosive or high degree of purity is required in process, like pharmaceutical industries, food industries. Okay. So this shows how the diaphragm valve operates. This is the diaphragm. So in the closed condition, diaphragm is pressed against the valve seat. The flow is not allowed. And you open the valve, the diaphragm is lifted inside the bonnet, and then it allows the flow. Pinch valve is again highly tight shut off. Means if you close it, there is no leakage to the other side. Pinch valves have high ability for tight shut off. The flexible sleeve allows the valve to close tight around the solids. So it can also handle the liquid with solids. Pinch valves are mainly used in controlling corrosive fluids and steam. In steam service also, this is very effective. So far we have seen on-off valves. Now throttling valves are control valves which do the job of regulating the flow rates, regulating the pressure, regulating the temperature, regulating level, etc. And you will find a similar type of valves used here also. Most important throttling type valve or control valve is the globe valve. Then we have needle valve. The names are all because of the valve trim inside. Okay, valve trim inside, globe valve, needle valve, butterfly valve we have seen, diaphragm valve we have seen, pinch valve we have seen, ball valve, plug valve, all the diagrams we have seen. Globe valve we have not seen, that I will show in the next diagram. So this is the globe valve. The path is like this. You can see the fluid has to flow in a zigzag manner. There is a lot of direction change for the liquid when it flows through the globe valve. And again, the usual components of the valve: hand wheel, the gland nut, this is the bonnet, and the body of the valve itself, this is the valve seat. Okay. Globe valve closes slowly to prevent fluid hammer in addition to efficient throttling. And globe valves will not leak under low pressure when they are shut off. So this is a leak-proof valve. Flow and pressure control valve generally use the globe pattern. When you want to regulate the flow or you want to regulate the pressure in an equipment, the globe valves are used. These are the preferred one. The flow pattern, if you see, it is like a Z. Okay, it goes through a zigzag pattern. So the pressure drop will be more in this case. And this diagram shows how the globe valve operates. This is the hand wheel, valve stem, packing, the valve body. Okay, this is the globe, the valve port, and the flow goes like this. Okay, this is the closed condition. And needle valve is again like your globe valve, but the valve port is very specific and very this one restrictive. So needle valve is a type of globe valve with a wedge having needle shape. It looks like a needle. It's a sharp one. It is used for precise control of flow. Very fine control if you want to achieve. You can use the needle valve for fine regulation. Rest all features are same as the globe valve, and you will see again the flow is in the zigzag pattern here. Non-return valves are the valves which allow flow in only one direction. The reverse flow cannot happen. It prevents the reverse flow. This is called check valve. Some people call it as a non-return valve, NRV, also called as check valve. It checks the flow from reversing. We have 4 different types of check valves: swing check valve, and wafer type swing check valve, dual plate check valve, lift check. We will see the pictures, then you will have a better understanding. The swing check valve, you can see this is like a plate, okay, which is resting on that. When when the liquid flows this way, it opens the swing check valve, and then the flow happens here. When it tries to reverse the flow, it will close it. Okay, the mechanical construction itself is a hinged connection. That is a cover, and this is the valve disc, which is nothing but a circular plate which is attached to the lever, and this operates through this pin which is secured on the valve body, and this is the seat ring. Okay, this is the body. So any reverse flow happening, this will close the valve, the disc of the valve, and then allow the flow only in one direction. Swing check valves can be installed in both horizontal or vertical direction. This is very important because some valves may not operate when it is in the vertical direction because gravity effect will be there. A swing check valve is like the wafer type, it is called. The valve disc has a specific shape and it operates like this. They are specially developed for applications where low pressure loss is essential. When the fluid flows, it allows full opening, you can see. When the valve port opening is equal to pipe ID, then pressure loss will be almost nil. So this kind of valves are called low pressure loss valves, and swing check valve is one such low pressure loss valve. Opening and closing of the valve will take place at an extremely low pressure difference through the valve disc. It's also compact design, like your butterfly valve, very compact design, relatively low cost. Dual plate is the name itself says there are 2 plates. Okay, you can see 2 plates spring loaded, and the dual plate check valve employs 2 spring loaded plates hinged to a central beam or hinge pin. And the flow decreases, the plates close by the action of the torsion spring. It's mechanically actuated by the spring loaded torsion springs. The flow reversal will not take place. You can see this diagram explains you how the dual plate check valve operates. So it is like this: when the flow is there, it opens like this. When the flow reverses, it will force these 2 plates to close the valve. So the flow, the direction of flow itself will prevent the reverse flow here. So this is partially open. This is a closed one. This is the valve. And then we have lift check valve, which is closure response of lift check valve is faster compared to swing check or shorter disk travel. Because of the shorter disk travel, it will, the inlet flow, it releases and lifts the plug, and then the flow is happening. When reverse flow comes, the plug will be sitting on the valve seat and tight close. This is called plug. This is the valve plug. This is the bonnet body. Other components will remain the same. Okay. Then we have another category of valves which are called multi-port valves. If you want to divert the liquid to different directions, more than one direction, it is called multi-port valve. We have a three-way valve and four-way valve. We will see the pictures, you will understand. It is a three-way valve. Okay, three pipes are connected to this valve. Okay, this is the valve. You have 1, 2, and 3. Okay, you can have the flow this way if the valve is put in this direction, or you can have the flow in this direction. This is a three-way valve, and you can divert the flow in two different directions. And this is the valve actually looks like. With the lever, you can reverse the change the direction. You can change the direction of the main flow. And four-way valves are there. You can see it is more complex arrangement. So I think by mistake my mic was muted. Okay. Now this is the multi-port valve. Here we have four directions. You can see the flow can happen in different ways as shown in these pictures. Okay. And this is one flow only. You want to send it to three different directions, or one flow in two different directions. Okay. Or either this way or that way. Okay, one portion goes here, another portion comes here. So different possibilities of the liquid passages are possible with this. As I told earlier, this kind of multi-port valves are used when you have two equipment operating in parallel and both in different modes of operation. So you want to divert the main flow to one vessel and send another stream to the second vessel. Okay, this is typical example is the air dryer used in the instrument air plant. Okay, the adsorbent in the one absorber will absorb moisture from the air, so that is under adsorption section. Once the catalyst inside the absorber is saturated, no more water can be absorbed, then you isolate the vessel and then divert the airflow to the parallel vessel which is having fresh catalyst. So when that is doing the job of adsorption, you can regenerate the already saturated catalyst with hot air. So two flows can happen, and you can divert the flows to the desired vessels. So then we go to the control valves. So far we have seen the flow control valves, means flow direction change, preventing the reverse flow and multi-directional flow, all these things we have seen. Now we see the control valves which are regulating the process streams to achieve the required performance, like flow control or pressure control or level control, etc. So control valves are used to control the conditions. Your main parameters are flow, pressure, temperature, and liquid level in a vessel. Okay. How do they achieve this regulating? You open between the full open and full closed positions. So the fully or partially opening or closing in response to signals received from the controllers. So these valves are actuated by the signals coming from the sensors. Suppose we have a pressure control valve. The pressure inside the vessel is measured by the pressure transmitter or pressure sensing element. That signal is converted into a control signal and it goes to the pressure control valve. So if the pressure is more, pressure control valve will open and allow the excess pressure to the flare. If it is normal, it will not operate. The vapor or gas outlet will go through the normal outlet line. Okay. And we always have a set point, because suppose you want to maintain the pressure at, let us say, 25 bar, means that is called set point. So it can vary between 20 to 30, etc. Plus minus some variation is possible. And in any given process, you cannot fix a particular variable at one value, because it is a dynamic environment. The fluids flow continuously, and there are process variations happening, and the individual equipments have their own operating characteristics. So there is bound to be variation in the process parameters. So these control valves try to reduce the variation. That's all. It's not stopping from deviating from the fixed value, but it allows minor variation around the set point. The set point and process variable are two important parameters in the function of the control valve. And sensors provide you the measurement, and the controller converts the sensor value to a signal which will go and operate the control valve. And control valve, we have three main parts. One is called the actuator, second one is positioner, third one is body. So this is the control valve. You can see from the outside, you can see this is a globe valve. The outside of the casing itself shows that we have seen the flow comes here, takes a direction change, and then goes out like this, correct? So if you see the ball body shape like this, you can say it is a globe valve. Okay, this is the actuator, which is the part which is responsible for regulating, adjusting the valve position. This is called the valve positioner. It will control the opening and closing of the actuator based on electric or pneumatic signals. So the process meets the specific parameter: flow, pressure, temperature, or liquid level. Body of the valve is, this is the valve body. Okay. Here your instrument air pressure will act on the diaphragm. This is a actuator part. So sometimes you see valve body is small, actuator is much bigger. Okay, because there is a diaphragm here on which the instrument air will come and compresses the diaphragm and makes the stem to close. Okay, this is how the control valve operates. There are certain classifications in the control valves, and control valves can be classified by a kind of the valve closure member movement. How the valve member inside the valve flow moves, that is denoted by the classification. The movement defines the geometry and operation of the valve. Okay, so control valve has two distinct types. One is leading to linear motion, another one is leading to rotary motion. Okay, ball valve here, the example, you can easily understand the ball is rotating inside the valve body, whereas linear motion is a globe valve. It raises up and down diaphragm. It's also raising up and down, of course. Gate valve also is linear motion, but gate valve is not used for regulation because of its slow movement against the operation. So pinch valve also we have seen. Okay, these are all the movement of the valve element inside is up or down. Okay, whereas in the rotary motion you have seen the ball is revolving, rotating inside. Butterfly can be revolving, and plug also can be the revolving type. Okay, it's just like ball valve, the only the shape is different. So linear motion valve is multi-turn valve. The closure member has a linear displacement. It moves upward or downward, and these are all operated through threaded system. Okay. The operation is slow, but it gives accuracy and stability to position the closure member. The closing member will be moving maybe a little bit slow, but it gives an accuracy in the control, accuracy in the control, and also it gives a stable operation. Okay. And types of valves in the linear motion, you can have globe valve, diaphragm valve, and pinch valve. General features: tortuous flow path. We have seen there is a lot of direction change in the valve, within the valve. So tortuous flow path, so generally the pressure drop will be more because of the direction changes which the process fluid is undergoing. But efficient throttling, very close control is possible, accurate flow control, and low recovery means when you open the recovery of the fluid, let us say pressure or other things, the recovery is lower. Rotary motion valve, we have already seen the closure member as well as its shaft turn 0 to 90 degree. That is why they are called quarter turn valves. They are quick opening closure valves. Types of valves, we have ball valve, butterfly valve, and plug valves. Here the features of these rotary motion valves are streamlined flow path, because ball valve, once you open fully, it allows the full pipe idea available for the flow. So the flow is streamlined, more capacity, they can handle more flow rates, can handle slurries. Slurry means a liquid solid mixture, and high recovery. So these are the advantages or general features of the rotary motion valves. So control valve, how much is the capacity of a control valve? It is measured through a parameter called flow coefficient. Okay. Flow coefficient is a constant value which is related to the geometry of the valve. Okay. And you have to understand that CV is a dimension number. It is not dimensionless coefficient. It is, though it is called a flow coefficient, it has units. So whatever units you use for flow rate, density, etc., that will have an impact on the CV value. Okay. CV is defined. How do you define CV? When you pass 1 US gallon, which is 3.78 liters of the liquid at 60 degree Fahrenheit or 16 degree centigrade, that is water, flows through an opening of such a valve during 1 minute with 1 psi pressure drop. So this is the definition. CV is 1 when you pass 1 US gallon of water at 16 degree centigrade through a valve for a minute, and during that flow rate it drops 1 psi pressure drop. So this is called the valve coefficient. It is specified by the Instrument Society of America, ISA standard S75.01. The valve coefficient can be calculated using this formula. Valve coefficient CV is equal to Q, which is volumetric flow rate, and G is the specific gravity of the fluid, and pressure drop, delta P is the pressure drop across the valve. So the specific gravity by pressure drop under the square root multiplied by the volumetric flow rate is the valve coefficient. So flow characteristics is the relationship between the flow rate that passes through the valve or flow coefficient and the valve travel. So we relate now, we know flow coefficient is in something to do with the flow rate of the fluid through the valve, and this flow rate is possible because of the movement of the valve, correct? When you open 60%, 70%, according to the valve opening, the flow rate varies. So your flow coefficient is related to the valve travel, that is percentage opening of the valve, varying from 0 when you fully close the valve, 0 flow. When you fully open 100% is the full flow. So accordingly the CV varies. The term should always be designated as either inherent flow characteristics or installed flow characteristics. Inherent is something inborn, and installed is when you install the valve in the system. Okay. Inherent is if you test the valve in the instrumentation lab without any attachments, let us say only pipes, incoming and outgoing pipes, and the valve is sitting there, you test the valve. That is the inherent flow characteristics. But you install the valve in the actual plant with a pump upstream and a vessel connected to the downstream of the valve, etc. It is called, under the installed condition, how the valve behaves. That is the installed flow characteristics. Hello, வந்துருக்கீங்களா? ஒரு நிமிஷம், நீ கொஞ்சம் வெயிட் பண்ணுங்களேன், நான் வேலையா இருக்கேன். நான் கூப்பிடுறேன். So the inherent characteristics is the relationship between the flow rate and the closure member travel. This we have seen as it is moved from the closed to open position with constant pressure drop across the wall. And these characteristics are published by the manufacturer. The company which manufactures the valves, they study the characteristics, and when you buy the valve, they give you the specifications of the valve characteristics, and we will see some graphs. Subsequently, we will see some graphs. Those are all given by them. So inherent flow characteristics are linear flow. Linear means it's directly proportional. If you open 50% of the valve, flow will be 50%. If you open 78%, flow will be 78% of the design flow. That is like that. Equal percentage flow characteristics is like exponential. Okay, under low opening conditions, flow will be low, but it increases during the middle stages of the opening, and towards the end it will be very high. So quick opening flow characteristics is like the valves which open very quickly or closes very quickly, they have separate characteristics. So installed characteristics we have already seen when the valves are installed with pumps, okay, piping and fittings and other process equipment, the pressure drop across the valve will vary with the flow rate and the plug movement through its travel. Okay. In general, as the valve opens, the resistance to flow and pressure drop across the valve will be decreased. As you all know, when you slowly open the valve, it allows more drop also reduces. Okay. When you totally close, maximum pressure drop. When you totally open, minimum pressure drop. In between, whatever percentage opening, the pressure drop vary according to the opening. So this moves the inherent characteristics. An equal percentage curve will be deviated to a linear curve. Okay. And linear curve will be deviated to a quick opening curve. This is the when you do the flow and pressure drop calculations, and the valve opens, the resistance to flow and pressure drop across the valve decreases. During the motion of the valve, the characteristics may shift from one type to another type. Like an equal percentage may shift to the linear type. A linear type may shift to the quick opening type. If you see the picture graph, you will be understanding better. This is the control valve characteristic curves, and this is the flow coefficient 0 to 100%. The valve opening from 0 to 100%. Okay. You see linear, as I said, linear is a straightforward relationship. Okay. 50% opening means you have 50% flow. You can very easily say. 70% means 70% flow rate. Whereas quick opening, what happens? Immediately after opening, it allows more flow. You can see the more flow, it reaches a peak and then it gradually goes to the 100% condition. Equal percentage doesn't start like quick opening, it starts slowly, the flow rate increases and it follows this curve. Equal percentage means if you open 10% of the valve, 10% of the flow, 20% of the valve, like that. Okay. And modified equal percentage is this one, and modified linear is this percentage. Okay. You simply understand linear and equal percentage, two important valve characteristics. Linear flow is valve with an ideal linear inherent flow produces flow rate directly proportional to the closure member travel. That is, it is directly proportional to the percentage opening of the valve, and it varies directly with the motion of the or the travel of the valve inside, valve trim inside. Change of flow rate is constant with respect to the closure member travel. That is, at 50% rated travel, flow rate is also 50%. And like that, valves with linear characteristics are often used for liquid level control and flow control. This you have to remember. This is very important. The bottom point is very important. The linear characteristics valves are more suitable for liquid level control and flow control applications. Equal percentage characteristic, the equal increments of the closure increment, the member travel will produce equal percentage changes of the flow rate. So it is an incremental change in the opening, and also the equal percentage flow rate will happen. The flow capacity increases exponentially. That's why you see the curve. It is an exponential curve. Okay. Equal percentage. If you see the curve, you see this is a uh, exponential curve. It increases like this. This is the path of the equal percentage. So equal percentage results in exponential variation of the flow rate with respect to the valve opening. The change in flow rate observed with the closure member travel will be relatively small when the valve plug is near its seat, relatively high when the valve plug is nearly wide open. So it varies continuously. It's not directly proportional, and in equal increments it is increasing. It is small when in the closed position and high at the open position. And what is the application? This is again you have to see the equal percentage flow characteristics are often used for pressure control applications. So this is the use of this equal percentage valve. Quick opening valves are on off. The purpose is on off. A valve with quick opening flow characteristics provides the maximum change in flow rate at low valve travels. Even if the valve travel is slow, the change in the flow rate is very quick, very fast. Flow capacity changes extremely for very small changes in the valve travel. The curve is basically linear through the first 40% of the valve. So as you open 20%, 20% flow, 30%, 30% flow, up to 40% it follows the linear characteristics. Afterward, the curve becomes flat and noticeably indicate little increase in flow rate as travel approaches the full open position. Means quick opening, the name itself says when you start opening itself, it should allow maximum flow. So within 40-50% of opening itself, in a linear fashion, the flow increases. After that, almost you reach a maximum flow. After 40% travel of the member, the flow rate not varies significantly. So this characteristic is often used in the on-off applications. Okay, they are not control application, they are only on-off, either open or close. The shape of the trim determines the valve characteristics. You see this is a flat type of disc, valve disc, and fast opening valve spindle here. Okay, this allows the flow like this, and this the quick opening is on-off valves. This kind of valve seat is preferred. Linear is you can see the shape of the valve member shape is like this. This is the space allowed for flow. So this shape helps for linear motion or linear characteristics. Equal percentage when you have plug type of valve member. The valve member is in the plug shape. You get equal percentage. So what are the process inputs to determine the type of valve, design of the valves? So process again generates all the basic physical properties of the fluids and conditions, operating conditions. So the process engineer performs the complete hydraulic design. We have seen already in the pump hydraulics, I have told you, for control valves, we assign a pressure drop in the circuit, usually 0.5 or 0.7 bar, etc. That's a standard number. Also, valve also like pump, you can do the inlet line side pressure. You can arrive at the inlet pressure to the valve, and from downstream you can calculate the line hydraulics and reach the outlet side of the valve. So the difference in the pressure between the two inlet and outlet pressures will be the pressure drop across the valve. Okay. So what are the conditions or data we give to the other disciplines, the process group for control valve data sheet? For any equipment, we make a data sheet like pump data sheet, column data sheet, vessel data sheet, etc., compressor data sheet. Same way we make data sheet for the control valves also. And this data sheet along with P&ID will be helping the instrumentation engineer to do the control valve sizing. We approximately do the control valve sizing by line hydraulics, as I told you just now, which will be fine-tuned by instrumentation group, and final characteristics will come from the vendor who supplies the valve. So what data we give to the instrumentation department is operating and design conditions like pressure and temperature, physical properties of the fluid which is flowing through the valve, composition for material selection, whether hydrogen sulfide is there, then you have to go for specific material for that. Gas blow by, this is a process condition. Sometimes, suppose you have a level control valve, it happens in the level control. When the vessel is fully drained, there may be gas escaping through the level control valve. This is called gas blow by. And if it is there, if it is possible, you have to tell the instrument engineer that gas blow by will happen, and this will be the gas flow through the valve. The valve should have always liquid flow, but in some extreme cases, gas will go through the liquid control valve. Those conditions we have to tell the instrument engineer. Failure positions will come little later, and mechanical CV limiter, you can arrest the flow coefficient by putting some mechanical restrictions in the valve. If it is required, we have to tell that. Volume bottle is required for certain cases. Whether the valve is continuous operation or intermittent operation, okay, that we have to tell. Extension bonnet required when you handle very cold or very hot liquids. Hand will become very hot, okay, you cannot operate it. So we break the spindle itself, and we allow the hot fluid or cold fluid temperature not reaching the hand wheel. So that is extension bonnet. And control valves, usually we provide a bypass or hand wheel to operate the valve. So bypass is to bypass the valve. When you have some problem with the control valve, you have a bypass to divert the liquid through the bypass line and take the control valve for corrections or repairs. So operating and design conditions, this we have seen right from our design criteria, design basis, etc. Operating and design process conditions such as flow rate, pressure drop, and temperature shall be specified. Okay. Flow rate will have minimum, normal, maximum. The entire range of flow rate you have to give. The maximum and minimum values of these parameters should cover the valve operating range. Okay. In case of two-phase flow, both liquid and vapor portions, we have to give the data separately. Physical properties, the main properties we need to provide are density, molecular weight, compressibility if it is a gas, viscosity for liquids, critical pressure, vapor pressure of the fluid. If you pass a liquid at boiling point, etc., we have to give the vapor pressure. Sometimes what happens, the valve also undergoes some pressure drop. Sometimes it may vaporize downstream of the valve, the liquid may vaporize. If your pressure drop is bringing the pressure of the fluid to its vapor pressure, then it will vaporize. In case two-phase flow, valve inlet applicable properties. Usually two-phase flow handling by the valve is somewhat a typical difficult situation, I would say. So when you have two-phase at the valve inlet, you have to tell the instrumentation engineer and the vendor, valve vendor, about the two-phase characteristics. So why we need the composition? That is mainly to see whether there are any harmful components in the fluid like hydrogen sulfide, carbon dioxide. BTX is benzene, toluene, xylene, etc. Ethylbenzene, styrene. And if there are chlorides are very harmful to the valve material, valve inside trim. Chlorides are generally harmful to the stainless steel material. So we have to select the material to face this corrosive environment and also to sustain the corrosive environment. Gas blow-by, I just now told, maximum gas blow-by flow rates considered for downstream relief valve sizing should be verified for a selected flow coefficient of the control valve. When a control valve is provided with a bypass, suitable design approach should be adopted. So, you have, by restricting the bypass valve operation through locking mechanisms, okay, and including flow through bypass also in the relief valve load calculations. When you have some safety relief valve in the downstream of the control valve, we have to give these bypass conditions and any restrictions in the bypass valve operation. These things we have to mention. We were talking about fail-safe position. Before that, I should introduce you to the operation of the valve. Okay, this typically there is a valve here. Here we show springs. Spring is actuating. Okay, when the load appears here, the control signal comes here. Pneumatic pressure comes here. So the control signal is converted. I think sometime back I told IP converter. Somebody asked about IP converter. The measured signal is an electronic signal which has to be converted into pneumatic. All the instruments are operated using the instrument air. Okay. Based on the signal strength and the IP converter output, the instrument air will come here. It will pressurize this chamber. Maybe it will lift. It will lift the disc against the spring pressure. Then it will allow open. This is fail closer. And when this fails, what happens? Suppose you don't get any instrument air here, the spring will be stronger, it will close the valve. Okay. The other case is fail to open. When the instrument air fails, we have to open the valve. In certain services, we open the valve because keeping the valve closed may affect the operation. Here it is exactly reverse. You have the spring here. Spring is here, and you have the diaphragm and the load. Instrument air comes here. Okay. Suppose the instrument air fails, the spring will push the diaphragm above and allow the valve to open. Keep it in the open condition. When instrument air fails, the valve will go to the full open position. In this case, when instrument air fails, the valve will go to the full closed condition. Okay. These are called instrument air failure. Failure, we mean failure of the motive fluid. The motive fluid here is instrument air. So air to open means when the instrument air fails, the valve should go to full open position against the valve springs to move them towards the open position. Similarly, whatever I explained with the diagram that is given in the text there, we have different fail-safe positions. So fail open, the condition wherein the valve closure member moves to the full open position when the actuating energy source fails. When the instrument air pressure which is actuating the valve fails, the valve will go to full open position. The exactly reverse is the fail closed position. When the air pressure decreases or stops, the valve will go to the closed position. There is another position called fail locked when the valve is, let us say, 50 or 60% of its travel. That time the instrument air fails, the valve will stay there. That's all. It will not go to the open or closed position. It will stay where it is. That is called the fail lock position. In certain process scenarios, this kind of fail lock condition is required. And fail lock drift to open, a condition wherein the valve closure member stays in its last position, then drifts slowly to the open position. It may be in the lock position and slowly it will go to the open position. The fail lock drift to close is the same way. It will first go to fail lock and slowly go to the closed position. So what are the conditions, fail-safe positions? In 80% of the applications, we go for control valves are specified for fail closed. Close the control valve and don't allow the flow through the control valve. Sometimes the valve should either fail open, fail lock, or drift slowly to either close or open position. So generally fail close open operation has to be done by the spring inside the actuator. In some cases, such as for lock position or a fail drift, an auxiliary power source is required. That is an air buffer vessel may be required. So you need to have some air available nearby the valve in a small container, that is called a buffer vessel, that will come into operation when you have a fail lock FL condition valve, which may go to open position slowly or close position slowly using the air in the buffer vessel. So what are the safety codes or process requirements for the failure position? Liquid control valve has to be fail close. Why? Because if you keep it open, the entire vessel will be drained. Okay, the vessel becomes empty. So which we don't want. So the level control valves will go to failure close position to prevent the complete drainage of the liquid from the vessel and allow any gas to flow through the liquid control valve. LCV could be fail open to prevent liquid overfilling if it is in inlet of the vessel. Let us say if the valve is on the liquid inlet to the vessel, then you can make it FO, because you don't want the liquid to continuously go and overfill the vessel. Okay. So it depends upon the location. If the level control valve is the outlet of the vessel, it will be fail close. If the liquid inlet line to the vessel is, it should be fail close. Okay. Fail open will allow overfilling, so it should be fail close. Pressure control valves usually will be routed to flare, has to be a failure close to prevent overloading of the flare system. However, the pressure control valve could be FO if flare system is able to handle the flow rate. It depends upon the capacity of the flare system, which is also designed by the process engineer. So depending on the operating scenarios of the process, you have to decide fail close, fail open, or fail locked, or FLDO or FLDC, correct? Mechanical CV limiter is you want to limit the capacity of the valve, that flow coefficient to a limit, maximum limit. In that case, it will be the mechanical limiter will be provided. Means this is a limiting arrangement which will not allow the valve member to move above that. Okay? This is not recommended unless it is essential due to any other design constraints. These are all very specific requirements. Don't think that mechanical CV limiter is there in all the control valves. It's not there. It is only for specific requirements where we want to restrict the capacity of the valve, and it should not reach a higher value than what you desire. Similarly, finalization of flare header or the PSV size based on assumption of control valve size may result in such requirement. This usually comes in the flare system lines. And mechanical CV limiter should be implemented only as a last resort and will be done after the acceptable given administrative procedures are agreed with and accepted by the client. So the mechanical CV limiter, very, very limited. In fact, I have not seen any such mechanical CV limiter in the processes I have come across. So just you should know that there is an arrangement called mechanical CV limiter for the control valve. That's all. If at all it is required, it has to be discussed with client, and the operating scenario should be fully explained and agreed, understood and accepted by the client. Then only mechanical CV limiter has to be provided. Volume bottle, the pressure control valves to flare, which are also used for depressuring the system, are provided with air buffer vessel. This FLDO, FLDC type of valve positions, fail-safe position, we have seen this buffer vessel. This also needs to be specified depending upon the project philosophy. Intermittent operation needs to be specified for frequent on-off services such as batch operations. This comes in the batch or semi-continuous processes. We will not come across in continuous processes. This is a requirement only for batch or semi-batch or semi-continuous operations. On-off valves are often required for services that are primarily non-throttling. They shutdown valves, we can say shutdown valves, and the level control valves of knockout drums. Okay? The level control valve in a knockout drum will not be continuously in operation because you all know vapor stream or gas stream comes into the knockout vessel with very small quantity of liquid droplets, which is separated by the demister in the vessel. Okay, so such knocked out little water liquid droplets will fall down and slowly collect in the vessel. Okay? In such cases, there is no big buildup of liquid in the vessel bottom, so there is a level control in the vessel also. It is connected to the level control valve, which will drain to the drain system. So once it reaches certain level, high level, the level control valve at the outlet of the knockout vessel will automatically open. There will be some mechanical arrangement. There is nothing like a control measurement, level signal and all. Usually they are called automatic level control valves. So they act on a mechanical system. When the you can see your toilet flush you have seen, isn't it? A toilet flush, once you flush, the water is gushing out and cleaning the toilet, then there is the water level is low. You would have seen if you open the toilet flush, you would be seeing a float, a ball float sitting on the water level. So the ball float is connected to the inlet valve in the inlet water line. So once you flush the toilet, water level goes down, ball is coming down, that will open the valve and water comes into the flush tank. Once it is filled up to the top level, the ball will raise and it will close the inlet valve. This is automatic level control. It's the simplest example I can give you. Extension bonnet is required only when you handle very high temperature fluids or cryogenic services, because even though you insulate the wall and all, there is a heat conduction through the stem. It can reach up to the hand wheel. So that is why a very low temperature, minus degree, cryogenic is below zero temperatures, and high temperatures may be 200 degree and above, the extended bonnet is provided. So the wall stem is split into two and they are connected in a different mechanical device. So the temperature effect in the process fluid will not reach the handle. This is called the extended bonnet arrangement. Bypass or hand wheel arrangement is the choice between providing either a bypass or a hand wheel for the control valve is made based on the size of the control valve. Hand wheel is preferred for control valves with inlet size of 8" and above. For valves of 8" and above. Bypass is preferred for control valves with 6" and lesser valve sizes. So we will quickly see the control theory. We have already seen on-off control and continuous control. And there is a continuous regulation, continuous control. There is a regulation of the flow or pressure or temperature or level through the sensor, and then the controller, controlling device, and the signal is conveyed to the final control element, which is the control valve. And on-off control, you can see it is a step change, okay, either on or off. Between these two positions, on or off, this is called a step change. On-off controls are step change valves. Okay? The on-off controller is generally more reliable and less expensive because it has two operations only, either open or close. The on-off controller is typically used in level controller, where the drain valve is opened only once the liquid level reaches some upper limit. This I told you, this is the example of the knockout drums. This may not be applicable for normal vessels with the level control. Okay, that will be a typical regulating valve. Continuous control, we have continuous control is often called modulating control. It means that the valve is capable of moving continuously to change the degree of valve opening or closing. It does not just move to either fully open or fully closed. It is always between the close and open positions. It's a continuous, the valve element is continuously in the movement. The continuous control attempts to correct the error between the measured process variable and desired set point. Okay, we keep a set point for the variable, and the sensor measures the variable and brings the measured value. The controller compares the two values, the measured value and the set point. The difference is called the error. That error is the driving force for actuating the valve. There are three control modes. We call it as control modes, control actions. Proportional, which is called P, integral is I, derivative is D. This PID controller is again a big subject, so I will just touch upon what is this. Examples of continuous control is a temperature of fluid within a continuous stirred tank reactor. So in a reactor, some inlet fluid is continuously coming. There is a mixing happening in the tank. Then some fluid is going out. You measure the outlet temperature of the vessel. It is a jacketed vessel where you use steam to heat the reactor contents. So the steam temperature, the outlet fluid temperature is measured and passes through a controller. When the set point is it is exceeding, the outlet temperature is more than the set point, then it will go and reduce the steam flow. If the outlet fluid temperature is less, it will open the steam valve more and allow more steam and increase the heating in the vessel. So this is a continuous control on the temperature. So the PID modes, you can see proportional is called P. Let us say this is the temperature, this is the time. So this reaction is going on. So you can see proportional control measures and acts like this. It is following this path. Okay, it takes some time to do the corrective action. This when the corrective action and the time are close, the set point is close. This is called the you have reached the required set point. So in a proportional controller, it happens with a time delay. Okay, the proportional controller is simple and stable. Fairly high initial deviation. This is called deviation. So high deviation in the initial phases, unless large P band is chosen, then sustained offset. This is called the offset is reduced. The difference is called the offset. Easy to set up, offset occurs. Okay. Proportional and integral. If you use the two modes together, this is called the PI controller. You can see it is almost matching with the time. That is almost matching with your required value. No sustained offset. Increases in proportional band usually required to overcome the instability. Possible increased overshoot to start up. Okay, you can see this is you see the difference here. Here the overshoot is more. Usually what the controller does, it takes some extra action. Okay, and then brings the controlled variable to the required set point by overshooting and trying to achieve it at a shorter time. So that is what you can see, more increase here, more difference here. This is shooting up. And then proportional and derivative mode, it is stable. Some offset is there, you can see, but the offset is very less. Rapid response to changes. So the action or the response is very fast here. Third one is PID. It's a combination of proportional, integral, and derivative modes. Will give best control, no offset and minimal overhead. You can see the different variation is very sharp compared to all the other three modes. More complex to set up. Okay. So this is in simple the proportional, integral, and derivative modes. This is again a big subject, so I'm not going into detail of these PID controllers. So we have come to the conclusion of piping valves and control valves. I think it is already 1.5 hours. So we have seen the functions of piping valves, control valves, and main components of valves and their types, and control valves and their classification. We have seen definition of flow coefficient and the flow characteristics of the control valves. And then control valve specifications and process inputs, types of control, PID control we have seen. And this is the end of this session also. I thank you all. Most of you might have been following these sessions regularly at least. And I hope we all enjoyed and have some good exposure to the process engineering design subjects. And I don't know, is there any mechanism to collect feedback? Prem, any mechanism you have to get a feedback from these?
Yes, sir. We will send a feedback form.
Okay.
End of the course.
Okay. I request all the participants to give your feedback. How was the presentation? You had any difficulty in understanding or any portion which was not clear to you? You can give a real good feedback. So don't hesitate. Even if it is negative, I accept it. I will correct myself. Okay. Feedbacks will help the trainer to correct himself. Nobody is 100% perfect. So the feedback is important to correct the, it is like you are giving feedback. It's a feedback controller. So it will reduce my deviations and offsets. Okay. So with that, I thank all the participants for your continuous following of the sessions and patient hearing. I hope this had given you some insight into the process engineering design subjects. With that, I thank you all and thanks for your cooperation and thank the organizers also. So now we are open to questions.
Yes, sir. I have received few questions.
Okay.
Why is pressure drop less in gate valves?
Because the geometry of the wall, I was talking about the geometry of the walls. Geometry of the walls is wide open. When once you open that wall element, the gate, this gate in this case, when it rises to the bonnet, the full gate rises inside the bonnet and the wall is fully open to the pipe. So you can say when the gate wall is fully open, there is no restriction for flow. The opening through the wall is equal to the pipe ID, pipe internal diameter. So the full flow happens. And during intermittent opening also, it's a small member and it's only a straight path. There is no zigzag path. In globe wall, you will see the path of the fluid is zigzag. Direction changes are there. That is why pressure drop is more. Gate wall, it is simple straightforward flow. Even if it is half open, the fluid flows straight. There is no direction change. That is the reason why gate walls are having less pressure drop. Yes. Next question.
Can we have the gate wall partially open for regulation purpose?
Usually gate valves are not used for close control because as I said, it allows flow freely through the wall and the restriction is not very much. And also its movement is slow compared to the other walls, ball wall, butterfly wall, or especially globe wall, its movement is slow. So when you want to effect a change, the change will come slowly, not the way you want. So that's why they are not good for regulating. When you want to close some, operate the wall and control the parameter in a close range, gate wall cannot do that. Okay, next question.
Why is the pressure drop low in some walls, high in the other walls, sir?
That is basically their construction, mechanical construction of the wall. Just now I told you, a gate wall or ball wall, when it is fully closed, the flow path is very straightforward and the full pipe opening is available. So they drop less pressure drop, whereas plug wall, the globe wall, etc., the path is very restricted. So it may not be. Even ball walls, we have two different versions. I forgot to tell you. Full bore walls are there, reduced bore walls are there. Full bore is a bigger size wall compared to the line size. So that when you open, the opening inside the ball is matching with the line ID. So, but they are costly. Full port valves are costly. So for normal operations, we use reduced port. Okay, so the opening allowable or available in the valve body is, and the valve element is less. So that is why the pressure drop is there. The valves which have more opening when it is open or a free passage, there is no zigzag flow directions, etc. Those valves will have less pressure drop.
So
So
will
next
the
one.
diaphragm get corroded when we use corrosive fluids in diaphragm valves?
Definitely, if you don't choose the material. So we know what fluids we are going to handle and their corrosive nature characteristics. So we have to select the diaphragm. These are metallic pieces only, but somewhat softer in nature. So the diaphragm material has to be selected based on the material characteristics.
Okay, sir. The next question is, can we completely close the multi-port valves? I see somehow flow is made to deviate in the directed way, but not able to completely stop the flow.
You close, suppose you have a three-way valve. Three-way valve is one inlet and going into either this direction or that direction. If you close the inlet valve fully, the valve is open. And if you have a four-way valve and having two different fluids flowing in two different directions, that anyway the inlet is one. You have to remember the inlet is one. If you close the inlet, the flow through the valve will be less. It's only combination. You want to divert the fluid through the valve in different vessels or different equipment. So that is what it happens.
Okay, sir. Where are mostly use of dual plate check valves? If I flow takes place, this valve can save for the use or not? And what are its advantages and disadvantages?
Advantages dual plate valve. Maybe I go back to the presentation. Dual plate. These are the ball valves. Non-return. Dual plate check valve employs two spring-loaded plates. This is the mechanical construction. The mechanical springs attached to them, the fluid pressure acts on them actually. Okay, there is no, you can see there is no hand wheel or things like that outside. All the check valves, you have to remember, check valves are self-contained operation. There is no outside human intervention to operate these valves. Depending upon the fluid flow and fluid pressure, these valves are operating. Okay. So if the pressure is more, they will push the valve and the flow will happen. When the pressure reduces, they will fall back. Similarly, when the flow tries to reverse, when suppose you close a valve upstream, you have a valve, you close the flow rate, what will happen? The fluid will try to flow back. In the reverse, it will close that. Dual check valve is one typical type, and it can have the opening. You can see the opening can be till it fully closes. The opening valve opening can be 0 to 100%. But there is I don't have any specific application for this. Maybe we have to search what kind of services will require. And most of the cases I can tell you, swing check valves are used in many services, and it can be installed in a vertical line or horizontal line. The gravity effect will not be there. This is one advantage. And swing check valve is very compact in design, and it will not occupy length, many more length of the piping. So the real application I have to see. I don't have a ready answer for this. Why where dual plate is used? Okay. Next question.
So what is volume bottle?
Volume bottle is a small vessel holding the instrument air. It will be under pressure and it will be connected to the valve diaphragm. And when the instrument air fails, the valve goes to certain position, correct? Fail open, fail close, or fail locked. And these volume bottles are there for the fail locked position. Suppose if the when the instrument air fails, the valve is at, let us say, at 60% opening. It will stay there, and you want to close it slowly to the open position or closed position. That time the air from this buffer vessel will go to the diaphragm and act on it, either to close or open. So how they operate is you have seen the spring positions I have shown in one slide, I think. Somebody asked about the multi-port valves. The multi-port valve different flows are shown here. Okay, and actuator. Okay. For this question, I have to take the see this diagram. This is seen fully, Prem. You can see the slide.
Yes, sir. Yes, sir.
See where you admit the buffer vessel air here means in this, if it is below the spring, it will close the valve. Okay, if it is above the spring, it will open the valve. So the buffer vessel is normally instrument air will do the work here. If the instrument air fails, then the instrument air from the small bottle will come and do the job. And that air is a quantity is sufficient to do the job of closing or opening. That's all. Any questions?
What is the difference between cavitation and flashing?
Cavitation is when the two-phase flow comes into the valve, this happens. It's something similar to your pump you have seen. Pump, when you pump a hot liquid at a boiling point, if the pressure drop in the pump is reaching the vapor pressure, then the liquid vaporizes inside the pump casing. Similarly, here also the liquid, if it starts vaporizing inside the valve, then it is called cavitation. Cavitation means the valve is designed for liquid flow, correct? If it sees both liquid and vapor, the valve will be struggling. Okay, it doesn't know what to do. So that is cavitating, and flashing is because of the boiling of the liquid. Vaporization of the liquid is flashing. Flashing is nothing but when you allow the liquid at boiling point, slight difference in pressure, it may reach the vapor pressure of liquid. So the pressure drop across the valve is sufficient to reach the liquid vapor pressure, then the liquid vaporizes, starts vaporizing in the valve itself. That is called flashing. And that flashing causes the cavitation. So it may damage the valve internals also. And the valve will be, when it is designed for liquid service, it cannot handle two-phase. So that is why I think in the input data we give to the instrument engineers, if the liquid is closer to its boiling point, you have to be very careful about the pressure drop across the valve. Also, if there is a two-phase flow in the inlet, you have to indicate that, and then they have to design a proper control valve to handle the two-phase flow. If flashing happens, downstream of the valve will have two-phase flow. So it all depends upon the pressure drop
Okay, sir.
across the valve. Yeah.
Will pressure drop affect the selection of valves?
Definitely. You want less pressure drop means you have to take that kind of valve which is not dropping much pressure. But you are more interested in regulation than pressure drop, then globe valve is the best. In most conditions, the globe valve is preferred for regulation. It has an impact on the type of valve. You are right. Next question.
So what is angled walls and where are they used?
Angled wall is your actuating member is at an angle. Suppose it can be a 90-degree turn. Okay, the line is taking a 90-degree turn. Then there you put the wall. That is the angle wall. That means the stem is not exactly perpendicular to the flow direction. It is at an angle, maybe 45 degrees. Okay. Angle walls are very seldom used where you have a space limitation or some physical restrictions in the arrangement of the equipment, etc. That very specific requirements. One more important angle wall is in the Christmas tree we have a choke wall. There is a choke wall. The choke wall is in the angle wall. Choke wall is an angle wall where we experience a very large pressure drop. So well fluid coming from the well reservoir is at a very high pressure, let us say 80 bar. I want to reduce the pressure to the operating level of the facility. Downstream the choke wall is, let us say, 30 bar. So I have to drop a very high pressure drop of 50 bar, means this kind of angle walls are used for very high pressure drop conditions. Angle walls are used. Very specific applications. Yeah. Next.
So can you explain about a self-regulating valve, PCV, and solenoid valve?
PCB I have missed in this presentation. Self-regulating valve is a valve with a sensor attached to that. Okay. There are two types of self-regulating valves. These valves usually come in the tanks. Tanks we use nitrogen atmosphere to keep the tank vapor space in the inert conditions. So continuously nitrogen will be coming in and there will be some bleed also. In those lines we put the SAPCV. It is called self-actuating pressure control valve, SAPCV. You can regulate based on the inlet sensing or outlet sensing, whichever you want to control. You want to control the inlet pressure to the equipment, then the sensing of the valve will be on the inlet side. If it is outlet pressure dependent, we will put the sensing. The valve will be called SAPCV. It is nothing but a valve with its own measurement and regulation. There is no separate sensor and controller, etc. These will have its own set point, its own sensing. Everything is contained in the valve. So these are called self-actuating valves. What is the next one he was asking? Second, self-regulating. What is the other one, Pray?
Solenoid, sir.
Solenoid comes in the instrument circuit. Solenoid is electrically operated. It will have on-off valve. Solenoid valves normally we don't use in the process requirements, but it comes in the instrumentation circuit. The fail open, fail close, things like that. The solenoid valves are operated to allow the instrument air into the diaphragm. So it comes in the instrument circuit, and solenoid valve is electrically operated. It has on-off position. So solenoid valves regulate the air flow into the control valve diaphragm. In the actuator, it will be attached to the actuator. So depending upon the signal goes and acts on the diaphragm and the solenoid valve, which allows the instrument air flow to the diaphragm of the actuator of the control valve. So yeah, yes, I answered both.
Yes, sir. How much sound effect in decibels is allowed for affecting operation?
It's a good question. Normally, control valves are little noisy. Whenever there is a gas control valves, it is more. You won't find it much in the liquid valves. And there is a let down. Suppose you have steam, you can easily see if you see the steam let down valves. Let down is pressure reduction. You are killing the pressure across the valve. Similarly, like choke valve. So when there is a large pressure reduction across a valve, it leads to noise and vibration. So these valves have to be mechanically secured. They should be provided enough mechanical support The line, both sides, inlet outlet lines will be anchored to the ground or to the structure nearby. It definitely leads to noise and vibration. Okay. If it is it can be measured. The vendor can give you what is the kind of noise levels it will generate. And if it is too much, you have to put some acoustic enclosure. You have to put some enclosure, which is like your silencer in the two-wheelers and cars. Okay. If you remove the silencer, you will hear a lot of noise. Whereas if you put the licenser, noise reduces, because licenser is doing the job of reducing the noise pollution. Same way, control valves also, when they operate with very high pressure drops and all, it creates vibration as well as noise. So there are means of reducing the noise. The vendor can specify the noise levels, and he can give the remedial measures also. Yes, next one.
Which are the valves used in processes involving fine or coarse solids and slurries?
Slurries we have seen, the butterfly valves are good. Similarly, gate valves are good, but not the this one, globe valve, etc. It will go and mess up the valve inside. So butterfly and gate valves are good. And what is the other part of the question?
Involving fine or coarse solids.
For solids, there are different dampers type of valves will come. This kind of valves may not come. Solid flow is usually through dampers. They are like wide open valves, and damper is nothing but like you can something similar to your gate valve. Okay, it's a flat element inside the wall, and that will be opening and closing. Typically, we have dampers in solid hoppers. When you discharge solids from hoppers, this kind of valves will be there. Another one I can tell you is the furnace controls. Furnace flue gas is going to the atmosphere, and we have a damper in the stack. So what we do, the flue gas is used for heating of boiler feed water. That is called economizer. Or you can use the flue gas to heat the some other hot steam like steam, etc. So part of the flue gas is taken upstream of the damper and passed through the economizer, and the cold flue gas is put back in the stack after the dampener. So the dampener you can control to regulate the pressure drop in the furnace, and also you can use it for reheating the boiler feed water, etc. So those valves, we don't use this kind of valves in solid service. They are different.
So is there any measure that can be taken to reduce wear and tear in equipments handling solids?
Wear and tear is the material and the corrosion allowance only. So you have to select the proper material of construction. In the solids control, and I have seen conveyors, hoppers, and then slide walls. They are called, sometimes they are called slide walls. They don't have very fancy internals like the control valves we have in the process services. There will be simple plate type arrangement inside. You pull the plate, and then it allows the solids to fall. And there is spillages may be there, but it is not so serious like a process services. Or wall leakage is a serious problem, because these are harmful fluids. There is a solids, especially coal handling, ash handling. If you go to power plants, you will see these solid handling devices. You have elevators, conveyors, and then slide walls. This kind of walls will be there. But frankly, I don't have details of those walls, solid handling, because we don't come across solid handling in the process plants. This will be more in power plants where you use solid fuels. Yeah, next question.
That is all, sir.
Okay, thank you, Prem. Thank you for your
Thank you, sir.
coordination. And Wednesday, you tell me the time and send the link. Okay.
Yes, sir. Sure, sir. I will share.
So this is
Note.
again for all the participants
Yes, sir.
with Arun and John. Okay.
Yes, sir. Yes, sir.
Okay. Thank you so much, and it was a long and interesting interaction with the people. Of course, not a live audience through webinar, but I am happy that more questions came in all the sessions. So that shows the involvement by the participants. Thank you, all the participants.
Sir.
Yeah, anybody wants to talk?
Yes, sir. One small query, sir. Did we have any what kind of fluid, which wall we have to use, like any chart or like that, really tabular form will be there?
Which one? Where?
I mean, like gate wall, global wall, whatever you explained for this
Uh-huh.
fluid, slide wall, like solid. So such kind of any tabular form will be available in the industry to use. So when for this fluid, we have to use this kind of wall, like that, any tabular
Uh,
form.
Actually, the service determines the material of construction. Okay. Service conditions determines the material of construction for the wall. Whether you have to make the wall in carbon steel, stainless steel, or any other material, or maybe the body is carbon steel. Inside you can give stainless steel lining or rubber lining, etc. Like you use, acids are corrosive, especially dilute acids are very corrosive. Okay, as my dilute sulfuric acid, etc., hydrochloric acid, they use mild steel with rubber lining. Okay, rubber is not having any mechanical strength, so you have to have outer metallic pipe. Inside you have the rubber lining. So there is no table as such. I don't remember. Maybe if you go in the internet, you search if possible. Okay.
Okay, sir.
Otherwise, the process industries, the different types of walls for different applications, we have discussed in this presentation.
Yeah.
And instrumentation handbooks, if you have, maybe you can go through, because I don't have any reference as such.
Okay.
Perry's handbook, you have the Perry's handbook.
Yes, sir. Yes, sir.
Perry's handbook, you see whether there is any chapter on control valves and all. Because I have a very old 6th edition. I have to see. But
Okay,
a
sir.
Perry's handbook also can give you some guidelines.
Okay, sir.
And selection is basically service dependent and operating scenarios. Okay.
Okay, sir.
Any fluid can be handled based on the material of construction. That is no problem.
Okay, sir.
Corrosive or non-corrosive, clean, whatever it is, the material takes care of it.
Okay, sir.
Yeah.
Sir, the small request is anything can we I mean, any presentation on about utilities like what you are telling in the steam, like fuel gas, like
Correct,
that.
correct.
Can we have any?
There is a separate. I have topics. I can tell you I have more than 40 topics with me.
Okay.
Utilities is one topic. Utilities, normally you have steam, cooling water, plant air, instrument air, nitrogen. All these things are called utilities. See, any
Okay.
process plant definitely depends on utilities. Without utilities, you cannot run the plant. It is like
Okay.
we live in the house, we need electricity, we need water, correct?
Okay.
Similarly,
Yes, sir. Yes, sir.
to achieve your process objectives or process operations, you need all these mediums.
Okay. Okay.
So they are called utilities. They are actually put in a separate location, the same plant. Process units will be in one block. And
Okay.
utilities, we have one more terminology called offsites.
Oh, offsets. Okay.
Offsites is little away from the main plant, and offsites is to store the raw materials and products. If you
Okay.
go to any refinery, you will see huge tanks, okay, to store the
Okay.
crude oil, which is the raw material. And
Mhm.
then you have a number of tanks for storing the products. You may have LPG is generally stored in spheres, okay, under pressure. And then
Okay.
naphtha, kerosene, diesel, these are also stored in
Floating
cylindrical
tanks.
tanks. And liquids which have high volatility, like crude oil, naphtha, they all
Mhm.
have floating roof tanks. Okay. Anything above naphtha like kerosene, diesel, and all, they will have a fixed roof tank. So the storage of raw materials, products, chemicals, etc., that is called offsites. And utilities block will have cooling tower for cooling water supply, boiler for steam supply, and the air compressor house to provide you the plant air, and then with the dryer we get the instrument air. Nitrogen, if you want, you can buy cylinders. If the quantity is small, requirement is small, we can manage with nitrogen cylinders. If the quantity requirement is more, you will have to have a nitrogen generation plant. And normally PSA, pressure swing adsorption process, is used to uh, generate this one, nitrogen. From air you have to get it. Okay. So
Okay, sir.
nitrogen plants are there. Some refineries, they need hydrogen for hydrocracker and all. They use hydrogen is one of the reactant along with the hydrocarbons. Then they have hydrogen plants.
Okay.
So that's a different subject. Then that will be one more thing.
Sir, can you take that
I
session,
agree
one
that
session?
it mainly covers the important key topics of the process plant, but
Okay.
there are so many other things. I have not covered compressors. Okay. I have not covered a flare system. I have not covered utilities. These are all. It will make the session more lengthy.
Okay.
And if you people show interest, you just write to iFluids, and we can try to organize some more sessions.
Okay, sir. Okay,
So,
sir.
so definitely, I appreciate your interest. So we can do that. Yeah.
Okay, sir. Okay, sir.
Okay.
Thank you, sir.
Thank you so much. See you all in the concluding session. My wholehearted thanks for all of you to be patient and continue this journey. I hope you all will have a bright future. My best wishes to you all. Thank you.
Thank you, sir.
Thank you.